Hello everyone. Today I am here because one of my friend Richa, her name is Richa, she is a basketball player. She is having a problem and I need your help in order to solve the problem. She belongs to a very good team A and she is participating in a match, in a basketball match where the opposition team, let's say the team B, after some time, their score are 65 and 67 respectively. And the time that is left in order to finish the match is only 0.8 second. She is standing at a distance of 8 meters from the basketball pole. And she needs to basket the basketball within the time of 0.8 second so that she along with the teammates can enjoy the day after winning a match. The height of the basket from the ground is 3 meters and her height itself, or you can say the height from where she will throw the ball is 1.5 meters. Now she wants to know, she is very curious that with what velocity she should throw the ball and at which angle she should throw the ball that the ball will go into the basket within this time interval. And she do not want to miss the shot. The direction is very clear. She has chosen the direction, only she want to know the angle and the velocity with which she need to throw. Now I am really very excited because I know that together we can find out the solution. But our approach should be in a gradual manner. We will first try to identify the nature of the problem, that what is the nature, what is the kind of problem that we are facing. Then we will try to deduce some fundamental concepts, ideas and the formulation to which we apply and we can find out the solution to our problem. So let us start by the introduction to the nature of the problem. As we can see, as we can witness, the problem of throwing a basketball is like a problem of a projectile motion. What is a projectile? A projectile is a body or an object which is thrown at some angle with the horizontal or the vertical, and it covers some vertical as well as the horizontal distance. And the overall motion is affected only by the gravity. The only force that affects this nature is the gravity. So this is how the projectile motion is introduced, that an object which is thrown only under the influence of gravity with some angle, by making some angle with the horizontal or vertical, is known as projectile, and the motion it covers is known as projectile motion. Now what happens when you throw an object only under the influence of gravity while with this some angle, making some angle with the horizontal or vertical? As you can clearly see in this problem, while throwing the basketball, when the Richa is throwing the basketball to the basket, what she is doing, that when she releases the ball, after releasing the ball is just under the influence of gravity. The gravity will try to pull down the ball, while the velocity with which she thrown the ball will try to move it in the vertical direction as well as in the direction of the throw. Now, this is the nature of the problem. The nature of the problem is projectile motion. Now we will try to understand the fundamental or the basic ideas of projectile motion. How to simplify this problem? This is a two-dimensional problem. Why two-dimensional? Because the motion is affected in two dimensions. If we take a coordinate axis, one is along the x, another is the y. Then what happens? When you throw the ball at some angle, let us say you are throwing the ball at some angle theta. At that time, the ball is covering some horizontal distance. Let us say after some time t, the ball reaches here. Then at this point, the ball has covered some horizontal distance, let us say small x at time t and some small y at time t. It means that when you are throwing the ball, you can simply say that this is the coordinate or position of the ball in this coordinate axis. Let us say it is x comma y is the position of the ball at time t. So it is clearly visible that the position of the ball is function of time. X comma y is the function of time. It means that what will be the x, what will be the y, it is function of time. तो time पे depend करेगा. In this way, we will gradually come to know that this x, the horizontal distance, the y, the vertical distance, they depend upon the time. But there are other factors which decide the position x and the y. What is that? This is the angle with which the ball is thrown. If I increase the ball, then you will see that after same time, for the time being same, the position xy will be changed. It means xy is also, displacement x and y is also function of theta. And similarly, you will find out that when the Richa was trying to throw the ball, she was releasing the ball with some velocity, some initial velocity. Let us say the initial velocity is u. So you will get to realize that the x and y is also function of u. It means the position of the ball will depend upon time, angle and the initial velocity. And of course, since the ball is under the influence of gravity, so it will be function of gravity. However, gravity will remain same. We all know that for the near the surface of the earth, the value of the gravity remains same. And for simplification, we will take it g equals to 9.8 meter per second square. So this is the value of g that we will be going to take. Now let us try to just explain or understand this diagram, that what this diagram is trying to represent. Now I am the observer and I have the position at the reference point. Before explaining this diagram or this figure, let me just give you a very brief introduction about some basics. We already know what is a point object. An object whose size is very small in comparison to the other distances to be measured or the distance it covers, then we treat the object as a point and we say that the object is point object. Here you can see that in the given problem or the question, the distance, horizontal distance was 8 meter, the height of the person was 1.5 meter, the height of the pole was 3 meter from the ground. What is the size of the ball that will cover the motion, or that will follow the motion? It is about some meters, some few centimeters. So it is very small in comparison to the distances to be covered by it. Therefore, we will treat the object as a point object. Now rather than treating the ball itself, we will treat each and every point as a ball itself. At any time, let us say at time t, its position is x. This is the x position, this is the y direction, y position at some time t. Now all the distances or all the observation will be made from the reference point. Generally people what observe that when they throw the ball to in upward direction with some initial velocity, they will see that initially the ball moves upward, then after reaching some maximum height, it falls back and touches the ground. So this and during this time, the motion is only under the influence of gravity. They know that because of the gravity, the object will fall down. So we want to know that what are the different terminology that we are going to use during our deduction of basic formulation. So we will see, we already know what is a projectile. A body thrown under the effect of gravity alone is a projectile. What is maximum height? It is the maximum displacement in upward direction or in the vertical direction, and we will represent it with the h max. I have already told you that when you observe or when someone observes, generally he or she will find that when you throw something upward, it will reach to some maximum height and then will start falling down. So the maximum height the projectile will cover is called as maximum height, and it is represented by h max. And since you have thrown the ball, so it will also cover some maximum horizontal distance before touching the ball or just upon touching the ball. So the maximum displacement in horizontal direction is called as range, and we will use the symbol r for its representation. And what is time of flight? It is the time during which the ball or the object will remain in the air or in the motion. Finally, now we are in a position to solve this problem and to deduce the basic formulation. But first of all, look at these three equations. What does they remind you? In high school, we have learned about these formulations. They are the three equations of motions during uniform acceleration, where v is the final velocity or velocity at some time t, u is the initial velocity, and a is the uniform acceleration, and s represents the displacement. And these three equations are applied in one-dimensional motion or motion in a definite direction. Now, what we are going to do in order to simplify this projectile motion, we will resolve this two-dimensional motion into two different directions. One along the x and another is the along y. This is the basic idea to simplify the projectile motion. And after resolving this motion along x and along y and deriving the formula, later on we will merge these formulas and will deduce a general formula for the projectile motion. So let us say the motion along x and motion along y. Initially, when the time is 0, we know that object is at reference point. At that time, x will be 0, y will be 0, where x is the displacement in x direction and y is the displacement in y direction. This is represented by small y, small x. After some time t, let us say after some time t, the object will be here. And initially, when time t was 0, you given it some velocity u with that theta angle. So the angle theta it is making with the horizontal direction or the x direction. And with the knowledge of vector or with the knowledge of trigonometry, we can resolve this u into two different directions along x and along y in two perpendicular components. One will be u cos theta, and this is the component along the horizontal, and the vertical component will be, the vertical component of velocity will be u sin theta. So the initial velocity when time t was 0, the initial velocity ux, initial velocity along x is u cos theta, and initial velocity along y uy is the u sin theta. After some time t, the object will reach here. Now what is going to happen, that since along the horizontal direction there is no acceleration affecting the motion, so the acceleration along the x will be 0. However, the motion in the vertical direction along y, it is under the influence of gravity. So the acceleration along y will be equals to g. Now, since this equation involves vectors, therefore it is compulsory or it is necessary for us to determine a definite Cartesian sign convention, a direction. So along y direction we will take the values or measurement as positive and opposite to y as negative. Similarly, along the x positive and opposite to x will be negative. As you can see that the velocity component is in upward direction, u sin theta is in upward direction, so it will be positive. While the gravity is in opposite to y direction, the gravity is acting opposite to y direction, so its value will be minus g. So acceleration along y is the minus g. So this is how we have resolved the two-dimensional problem into two different directions. Now what we are going to do, we are going to write the three equations of motions for both these directions. After some time t, what will happen? We will write velocity along x equals to ux minus plus at, ux plus at. Similarly, the displacement x, displacement is the x, the value is x at some time t, xt equals to u into t plus half a t square. And similarly, we will write vx square, velocity at time t in the x direction, minus ux square equals to 2ax. And similarly, I will write for the y direction. Vy equals to Uy plus At. Yt equals to, yes, Uy into T plus half Ay, this is Ax, this is Ax, this is Ax, Ay T square, and Vy square minus Uy square equals to 2Ay into y displacement. So these are the three equations of motions for two different directions. Now let us look at the more basic formulas that we need to apply in this projectile situation. We know that since acceleration along the x is 0, we have seen it. So since acceleration is 0, then we will say that Vx is equals to Ux. It means the velocity in x direction do not change with time. So Ux for along x, I can write along x and along y. Along y. Along x, I can say that Ux equals to Vx. That is, the velocity component along the x direction do not change it. So this equation is redundant now. Again I can say, since the acceleration is 0, so this component will be 0. And since this component will be 0, so I can write x after some time t, displacement in horizontal direction after some time t will be equals to Ux into t. And similarly here, since Ux equals to Vx, we came to know Ux equals to Vx, therefore this overall component will be 0 and it is of no use. So simply we can say that Ux equals to Vx, and we derive to a single formula that x equals to, or x at some time t equals to Ux. What is Ux? U cos theta into t. So this is the formula that we will use along the horizontal direction. Along the y, let us see what will happen, that Vy equals to Uy, and we know that acceleration is in negative direction, minus g. So we will take minus, in place of plus we will take minus Ay minus g into t. So this is the first equation that we will use, Vy equals to Uy minus gt. The second equation is the y after some time t equals to Uy into t minus, again because acceleration is negative, minus g minus half g t square. So this is the second formula that we will use. And later in the third formula we will see that Vy square minus Uy square will be equals to minus 2gy, and this is the third formula that we will use. Now we are heading towards the most entertaining or most important part, that is the derivation of different parameters like the range, maximum height, time of flight, and we will derive it with various concepts that we can apply. Let us first of all start with the derivation of maximum height. That what will be the maximum height the projectile will achieve, h max. In order to find out the maximum height, as you can see here, the maximum height is in vertical direction. So we need y component of the motion. This is the yt. Here I have written all the formulas that we derived earlier in a single place, so that we can take these and reduce the parameters, different parameters like maximum height, range, and the time of flight. So for maximum height, what we can see here, that when the object will be at maximum point, what you will see, that the velocity or the vertical component of velocity at the maximum height will be 0, because there will be no further movement in the vertical direction. At this point, there will be no vertical component of the velocity, because if there will be some vertical component, either the object will be directly moving downward or will be directly moving upward. For this time, but at this position, the object nearly, for very small time, the object moves in a horizontal direction under the influence of gravity. It means at this point of time, when the object will be at maximum height, there will be no vertical component of the velocity. It means at this point the Vy will be 0. And since Vy will be 0, and we need to find out the displacement, the maximum displacement, that is y. So we will use the formula, the third, this equation. So we will use this equation directly. So by using this direction, we will come to know that minus uy, what is uy? U sine theta square equals to minus 2g, and what is y? The y we have taken is the h max or capital H, because at this point Vy will be 0, so we have used the value 0. From minus to minus cancel, we can write u square sine square theta equals to 2gh, and we can write it as h equals to u square sine square theta by 2g, and this is the maximum height. This is the formula to obtain maximum height. So if you know the velocity with which you throw, if you know the angle with which you throw, then with the knowledge of gravity you can find out what is the maximum height to which the projectile will reach. So this is the formula that you should remember. In order to remember it in short, you can also remember it like this, that maximum height equals to, what is u sine theta? This is velocity in y direction. So velocity in y direction, and it's the square, we have taken the square upon 2g. So this is the formula for the maximum height. Now let me tell you that there is no hard and fast rule that you need to apply only this concept, that at the maximum height the vertical component will be 0, and you apply this equation and derive the formula for maximum height. You can utilize the other concept also. You don't need to panic, or you don't need to stick to only a single concept for deriving any parameter. You can utilize multiple concepts to find out or to derive a single the value of a single or the formula of a single parameter. Like I'm saying that we can also derive the formula for maximum height by using the concept. The concept is very simple, that let us say when the object will be at maximum height, then what will be the time? By observation you can see that the total time for the projectile to reach here, let us say this is capital T, time of flight. Then at the half of the time, within the half of time, the object will reach here. It means at time equals to T by 2, which is the half of the time of flight, the object will be here. And if I know the time of flight, so in this formula, using the value in this formula, by using the value of the time of flight, I know the value of time of flight, t equals to t by 2. Putting the value t equals to t by 2, and then we already know the value of u, we already know the value of theta, so we will get the yt. That will be maximum height. I will derive it later when I will derive the t by 2. So, or we will find out the time t. So let us go to find, or let us move towards finding the time of flight. Now again, there are two ways to define the time of flight. Let us see what are the two ways. As I have already said that there is no hard and fast rule to stick on a single concept, time of flight t. The first concept says that when the total time will be taken, at that time the vertical displacement, you see the vertical displacement will be 0, because after time t, when the motion will be complete, there will be no vertical motion, or there will be no vertical displacement. It means after time t, or at time t, the displacement y will be y at t equals to 0. So this is a one concept that we will utilize. Or second concept says that when the object will be at maximum height, in the middle of the motion, then the time of flight will be t by 2. And at that time, we already said that the vertical component of velocity at t by 2, the vertical component of velocity vy will be equals to 0. So here we will use both these concepts and try to deduce the time of flight, the formula for time of flight simultaneously. So when, let us say, by using first this equation, that at the maximum height when the vertical velocity is 0, then the time will be t by 2, which is the half of the time of flight. So what will be the t? And in this case, we need to use this formula, because we know that Vy is 0, we know the value of g, we have already provided the initial component of velocity along y, and we need to find the t. So t is the only unknown here. So we'll use Vy equals to 0 u sine theta minus g, and time is t by 2. Using this formula, I can say that time t equals to keeping moving to this side will be equals to 2u sine theta by g. Time t equals to 2u sine theta by g. Or you can say time of flight equals to 2u sine theta. What is u sine theta? Ui by g. So this is the formula for time of flight, the entire time that the projectile will take. And you can see here the time of flight depends upon the vertical component of velocity as well as the angle of throw. Second concept, by using the second concept here, yt is 0. When the time of flight or the total time will be taken, then the vertical vertical displacement, not vertical component of velocity, but the vertical displacement will be 0. So how we will derive the formula of time of flight? It is by using the equation when yt is 0. Using this equation, we know yt is 0, we need to find the t, we need g, we also know g, and we already know the value of u sine theta. So what we will use? We will use this formula, and using this formula I can write yt equals to 0 u sine theta into t. What is t? T is now time period t, because the y component will be 0 at time t. Or simply you write t equals to u sine theta. Initially you write t minus half g t square. Taking t common, you will see that t into u sine theta minus half g t equals to 0. This equation indicates two solutions. One, t equals to 0. It means that y will be 0 at time t equals to 0, which is already we have shown in the initial time where we were trying to deduce the formula. And other equation says that u sine theta minus half gt equals to 0, and this is when the time will be equals to t. So we will get u sine theta minus half g t equals to 0, and you will get t equals to u sine theta into 2 by g. This is the time of flight that we have derived by two ways. I hope that now you are finding it very easy, simple and amazing, that you do not need to remember these formulas. If you know the concept, if you know how to apply the formulas and the physical limitation of the projectile motion, then you can derive the formula of Hmax and the time period. However, the formula is also very simple to remember. For maximum height, the vertical component of velocity, it's a square by 2g. For time of flight, the vertical component of velocity, twice the vertical component of velocity upon g. Now, we are going to derive the formula for range. Now, range is the horizontal displacement after the completion of the motion or after the time of flight. And so it becomes easy because we need to know is that we need to use this formula simply. So range, let us say range is the r represented by r. So r is equals to at time t. So range will be at time t equals to time period. So I will write this value. R equals to u cos theta into t. And what is the t? T is the time period. And the value of time period is 2u sine theta by g. So I can write it like r equals to u by g into 2 sine theta cos theta. And by using the formula of trigonometry, I can write it r equals to u by g and then 2 sine theta cos theta is sine 2 theta. sorry, have to multiply this here, so I will multiply it here, and this will be u square by g. I need to remember this, u square by g. So it will be u square by g sine 2 theta. So u into u cos theta sine theta. Okay. So u square by g sine theta. This is the formula for range. Range equals to u square sine 2 theta by g. So this is the formula for the range that all you need to remember. So these are the three basic formulas that you need to know, and by simply applying these formulas you can help Richa in solving her problem. Now after this we will directly head towards the solving the problem of Richa and find out the velocity and the angle of throw which she should make while throwing the ball in order to win the match. Hello friends, finally the time has come that now we need to help Richa. We have all the ingredients that we required. We came across the basic concepts, the derivation, the formulas. Let me just give you the hint, and then you post your answers that what should be the velocity and the angle with which you should throw the ball in order to basket within the time limit and win the match. The hint is that the problem involves two variables, and in order to solve the problem with two variables you require two equations. And we came across three fundamental formulas, and we came across the four formulas here. You need to apply, in order to solve this problem, you need to apply these formulas in order to solve the problem. Like, we know the distance, the horizontal distance is known to us, that it is 8 meter. But when the position is 8 meter, you know, when x is 8 meter, at that time there will be some value of time t, and the time t is already known to us. With this help we can say that u cos theta is equals to xt by t. The time, that is the limit, and the horizontal distance, that is the 8 meter. So this is the one equation that you can use. Another equation is that the y component is also given. The y component, the displacement in y direction is 1.5 meter, not 3 meter. Why? Because the person itself is throwing the ball from the height of 1.5 meter. So in this case, the only distance the ball need to cover is the vertical distance. The only vertical distance the ball need to cover is 1.5 meter. So you can say here that yt, using this equation, yt equals to u sin theta t minus half gt square. So time is already known to us. So we can apply yt equals to u sin theta into t minus half gt square. So using these two formulas or these two equations, we can find out the solution to the problem. Now you apply these formulas, put in the values, and if you are right with your suggestion, with your help, then she would win the match, she will win the match, otherwise she will lose the match. Let us see how many of you give the answers correctly. So your answers, post your answers in the comment box. Till the time, stay tuned with the channel, keep watching the videos, subscribe the channel, share the video. Thank you.